projectile motion refresher. So this is a refresher, not for introductory students, but maybe you like it anyway. So this is really for my students in advanced classes, just so that we're clear about projectile motion. Okay, so I'm going to do this the advanced physics way. Okay, so here I have a ball or projectile launched at some initial velocity v0 at some angle theta, and there's no air resistance. So in that case, at some point, the only force acting on it is the gravitational force, so that I can write the following is true. X double dot equals 0, y double dot equals negative g. Okay, so I know those two things are true. And again, the double dot means second derivative, or the acceleration, and the acceleration. So it accelerates in the y direction, negative 9.8 meters per second squared. The acceleration in the x direction is 0. Okay, now let's start with the x motion first. So since the x motion, the acceleration is 0, I can write the following equation of motion. Now, you could integrate that twice to get this, but I hope you've done that before. So I'll just skip to it. X as a function of t equals x0 plus vx0 t plus 1/2 at squared, which is 0. Okay, so this is my x equation of motion. And x0 is where it starts, vx0 is the x velocity, but vx0 equals v0 cosine theta. So if it's launched at an angle, this velocity is the x component of that total velocity. Putting that all together, x as a function of time, x0 plus v0 cosine theta t. And this assumes that time starts at t equals 0. It's at x equals 0. This is really the better equation. If I know my velocity and my angle, I can find out wherever this is at any given time. So I plug in my time, I know where it is. Done. That's it. Okay. Now that doesn't tell you everything. That doesn't tell you how far it goes and all that stuff. If I know how long it takes to get back to the ground, I can find how far it goes. Okay. So, but that's important. Now for the y direction, you can integrate twice and get the kinematic equation in the y direction, and it would look like this. So it's just like this, except that we have that acceleration term on there. And it's negative because the acceleration is negative g. We normally use g as 9.8. So the acceleration in the y direction would be negative 9.8. So it's just a convention. Okay. And again, I can find the initial y velocity, and I can write this as that's sine theta. This is not, the t is not in the sign. Okay, now let's use these two equations and do something with it. And do something like, how far does it go? How far does it go when it hits the ground? How high does it go? We could do all those things. Now the one key thing about these two equations is that they're independent, except for the time. So whatever time it takes to do something here, it's the same time over here. Okay. So if I look at the motion of this going over there in the vertical direction, it's just like this going up and coming back down. Oh, that's too high. And the y motion is just moving along that way. But they take the same time. So it's two one-dimensional problems, and we can do that because the acceleration is constant and in one direction. If you have a non-constant acceleration, don't do this. Okay. If you have air resistance acting on the ball, then you can't write this. So that only is determined by integrating this twice, and that's a constant. Okay. Okay, so where does it land? If I knew the time it takes to get here, I could plug in that time and find out the position. So I'm going to use this equation to find the time. Now, what do I know about this motion? Or actually the one-dimensional motion of it going up and down. I know that, and this is a partial cheat, you can actually figure this out. But I know that if it goes up with initial velocity v0, when it gets back down to that point, it'd be going negative v0. So it's going to have the same velocity but in the negative direction. So I can say, let's look at this motion starting from here to there. It starts at y equals 0. It ends at y equals 0. So I have 0 equals 0. Oh, I don't even need that because I'm just have the initial velocity. Okay. So then I have plus v0 sine theta t minus 1/2 g t squared. And I want to solve for t. So let's solve this for t. So I get 1/2 g t squared equals v0 sine theta t. I can divide both sides by t, and I get 1/2 g t equals v0 sine theta. And then I multiply 2 by 2 and divide by t. G, t equals v0 sine theta 2 over g. That's the time it takes to go up and back. And let's just check. We should check if it has the right units. Okay, so here I have 2 has no units. V is meters per second. Sine has no units. And I divide by meters per second squared. So the meters cancel, 1 of the seconds cancel. I get 1 over seconds, which is seconds. 1 over seconds, which is seconds. So it at least has the right units. Now I can put that back in over here. And I can solve for the position at that time, because I know the time. So let's solve for the position x. This is not x as a function of t. This is just x final. So it's going to be the initial x plus v0 cosine theta times t, and this is t. So that's going to be 2 v0 sine theta over g. So x final equals x initial plus 2 v0 squared cosine theta sine theta over g. And that's your answer. Okay. Let's check the units, right? You should check. Okay. So this has to have meters. That's meters. 2 has no units. We get meters squared per second squared for v squared. So meters squared per second squared. No units, no units. Divided by meters per second squared. It's the only thing that doesn't cancel is meters. So that does have the right units. Also check this out. You'll notice that as theta increases, what happens to cosine theta? When you're less than pi over 2, this decreases. This increases. So, but they increase and decrease the opposite amount. So you're going to get the combination of these two will be the maximum at pi over 4, 45 degrees. Okay, that is, so you get the longest range on flat ground at pi over 4. Okay, so you can see how you manipulate these equations for just normal projectile motion. It's all about just algebraically solving for things. So don't get too freaked out now. Wait till you get into things like air resistance, stuff like that. Or shooting up at an incline. Or what if I want to shoot this off a table and it doesn't land at the same height? Well, that's not so hard to fix. This is not 0 then. And that does make this equation hard to solve. You get the quadratic equation, and you have to use that. But it's the same idea. So I want you to try that, try some other things, and we'll talk later.